Having trouble preparing for the final? Well, so is Andrew.
So Jordan and I are here to teach Andrew and all of you the art of balancing a chemical equation.
Well, first off, what's a chemical equation?
Good start, Andrew. A chemical equation is a chemical reaction written out.
On the left side of the equation are the reactants, and on the right side are the products.
What's the arrow in the middle mean?
Well, Andrew, the arrow in the middle means simply reacts to form or yields.
You guys said something about balancing equations? Well, why do we have to do that?
Due to the law of conservation of mass, we must balance all chemical equations.
The law of conservation of mass simply states that matter cannot be created or destroyed in a chemical reaction.
Well, then how do we balance a chemical equation?
You have a lot of questions, Andrew.
To have a balanced chemical equation means that you have an equal amount of each element on the same side of the equation.
Coefficients are put in front of each element or compound in the equation.
You want us to do an example for you, Andrew?
Well, it's on the next slide. Might as well have to.
So our example is sodium chloride and fluorine react to form sodium fluoride and chlorine.
So our first step is to set up a chart with reactants on one side and the products on the other, represented by R and P. Then we fill in the chart with the current amount of each of the elements on each side. Then we must make sure each element has the same amount on each side by placing coefficients before each substance.
Sounds good. Well, are there any different types of chemical equations then?
Actually, Andrew, there are. There are 6 basic types of chemical reactions we must know. First, the decomposition reaction, which is the single substance undergoes a reaction that produces 2 or more simple substances.
Then there's the single replacement reaction, which is when one element replaces a similar element in a compound.
Third, the double replacement reaction, which is when 2 ions of 2 compounds exchange places in an aqueous solution to form 2 new compounds.
Next, there's the synthesis reaction.
Also known as the composition reaction.
Yes, Andrew, the composition reaction, which is two or more simpler substances combined to form a new compound.
There's also the combustion reaction, which occurs when the substance combines with oxygen, releasing a large amount of energy in the form of heat and light. These reactions often catch fire and cause explosions of various ranges.
Finally, the acid-base reaction, which is similar to a double replacement reaction, but acidic levels cancel each other out in this.
Why do I need to know all of these?
You must know all of them so you can be able to predict products.
Like seeing into the future?
Kind of.
To predict the chemical products, we must first classify the type of reaction taking place using the types of chemical reactions we just learned. Then, we must complete the products on the side of the equation as shown in the example.
And that's essentially all you need to know to balance chemical equations.
Wow, that is a lot. I'm gonna have to study then.